Hello everyone, welcome to my YouTube channel. Today we are going to solve this kind of PDEs. We are asked to solve completely. So make sure you subscribe to my YouTube channel. So this kind of PDEs, you are asked to solve completely. So you have the homogeneous part. This is the homogeneous part and this is the non-homogeneous part. So first of all, you solve the homogeneous part, this part. So in our solution, we have d1 squared plus 3d1 d2 plus 2 d2 squared z equal 0. Now to solve the homogeneous part, let m be, okay, let's first use these concepts. We divide all through by d1 squared. So d1 divide all through by d1 squared. So if you divide all through by d1 squared, you will have 1 plus 3d2 over d1 plus 2d2 over d1 squared equals 0. Now from this one, let m be d2 over d1. If m is d2 over d1, if you substitute here, you have 1 plus 3m plus 2m squared equals 0. Now having this one, you can use quadratic formula and solve. So by quadratic formula, we have m equals to negative b plus or minus b squared minus 4ac square root divided by 2a. Now this implies that our m is, this is our a, b, c. Now negative b is negative 3 plus or minus, what is b squared? 9 minus 4ac, 4 times a and c, so it will be minus 8 because of 2. So 2 times 4, so 8 square root divided by 2. So our m equals to negative 3 plus or minus 1 over 2. So our m1 will be negative 3 plus 1, which is negative 2 over 2, which is 1. No, which is negative 1. It's negative 1. M2 is negative 3 minus 1, which is negative 4 over 2, which is equals to negative 2. So our M1 is negative 1, our M2 is negative 2. So if you substitute here, now you have m plus 1, m plus 2 equals 0. So m plus 1, m plus 2 equals 0. So if we having this one, we know that to get the complementary solution, to get our ZC, we know that m is d1 d2 over d1. So d2 over d1 plus 1, and then d2 over d1 plus 2 equals 0. We can multiply both sides by d1, multiply all through, multiply all through by d1. So we have our ZC will be Okay, we'll call it ZC when we get our final solution. So this one will be D2 plus D1, D2 plus D1, and this one will be D2 plus 2D1 equals 0. Now from this one, there's that concept. We know that our ZC equals to exponential power negative Ci over AI of x. Then we have Bix minus Ai. Now from this one, we know that f d1 d2 should give us a1 d1 plus ai d1 plus bi d2 plus ci equals 0. Now from this one there is we don't have our ci. We have our ai and bi. We don't have ci. So if ci is 0, since c equals 0, then exponential power 0 is just 1. Exponential power, anything, it is 0 over a1. What is our a1? It's just 1. 0 over 1 is just 0. Exponential power 0 is 1. So this concept will be 1. This part will be 1. So our ZC will be the remaining part. So we'll have, what is BI? In this case, here, A1 is 1, B1 is 1, and here A2 is just 2, and B2 is just 1. So we are going to have phi 1 of B1 is just 1. So we have x minus AI is just 1. So x minus y plus phi 2 of AI is 2. So we have 2x minus y. So this is our complementary solution. So having the complementary solution, we can find the particular integral. The particular integral is the non-homogeneous part. So to solve the non-homogeneous part, you can lab here. To solve the non-homogeneous part, the homogeneous part, not the non-homogeneous part, this part. So we have the particular integral, So to solve the non-homogeneous part, or d1 squared plus 3d1 squared d1 d2 plus 2 d2 squared z, this is z, equals to x plus y. Now this is just let's say d1 squared of 1 plus 3 d1 d2 plus 2. No. If you factor out d1 squared, we have 3d1 d2 plus 2d2 squared. If you factor out d1, you get 1 plus 3d2 plus 2d2 over d1 squared. If you multiply this one inside, if you multiply this one all through, you'll get this. If you multiply d1 with this, you'll get back this. Z equals to x plus y. Now this one is the same as saying our zp will be equals to 1 over d1. So we need to take this the other side, so we divide both sides by this one. Dividing both sides by this one, we have 1 over d1 squared of, now if we divide this on the other side, it's just saying this one power negative 1 if we raise it up. So we have 1 plus 3d2 over d1 plus 2d2 over d1 squared power negative 1 because we've divided it both sides. Then we multiply by x plus y. Now we can open up this one. So if you note this one, let this one be a, this one be a. So if this one is a, we have this concept 1 plus a power negative 1. This is the same as saying 1 over 1 plus a. 1 over 1 plus a. So this is the same as just saying 1 plus, it's just same using binomial theorem. This is just 1 minus a plus a squared minus a cubic plus blah 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 blah. So using this concept, we'll have that our zp is just equals to 1 over d1 squared of, now this one 1 minus, this is our a, 3 d1, no, d2 over d1 plus 2 d2 over d1, and then we go to addition plus 3 d2 over d1 over d1 plus 2 d2, this is squared, plus d2 over d1 squared, but this one is squared, so plus blah 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 blah, then you multiply by x plus y. So having that, at least we have removed the negative 1 part by binomial theorem. So to solve our zp, we have zp should be equals to, now this multiply it inside here, we'll get 1 over d1 squared of x plus y. And recall, we can recall, so before, sorry for this, we can recall it here, nb. Our nb is that d2 is the same as saying partial derivative of something with respect to y, and 1 over d1 is just saying the integral of with respect to x, something dx. We don't have the dependent variable here, so with respect to x. So 1 over d1 is integrating something with respect to x, and d2 is just the differentiation of something with respect to y. Now we can proceed now. So our zp, we can write there instead of struggling. Write it here. So if you open that equation, you have zp equals to 1 over d1 squared of, if you open x plus y, you multiply with 1, it's just x plus y. And then x plus y you multiply with 3d2 over d1. So if you multiply x plus y with d2, you have to differentiate this one, as we said here. You have to differentiate this one with respect to y. And if you differentiate this with respect to y, you get just 1. Then that one you need to integrate it with respect to x, because 1 over d1 is the integral. So you get, if you differentiate this with respect to y, you get 1. And if you integrate it with respect to x, you get x. So you have minus 3x. Minus 3x. Now, let's go to this one. You multiply this one with this factor here. So, if you multiply this with d2 squared is differentiating this twice. If you differentiate this with respect to y, you get 1. 1 with respect to y is 0. So whenever if you integrate 0 with respect to x, you get 0. So plus 0. Now if you get plus 0, now we can proceed. Our ZP equals to, so you don't have to proceed, because if you open this equation, you'll get something squared, and if you differentiate this equation twice, you get 0. So this is 0. We have 1 over d1 squared of x minus 3x. So you have y minus 2x. So having y minus 2x, now we said that d1 over d1 is just the integral with respect to x. Now we have to integrate twice so as to get rid of this d1 squared. So our ZP will be equals to, now 1 over d1. If we differentiate once, you'll get rid of 1 d1. And we remain with 1 over d1. So if you integrate this with respect to x, you get y x. This is a constant, and a constant, if you integrate a constant, you get something with respect to that x. So if you integrate y, you get xy. We can write it xy instead of yx. So you get xy. And then minus. If you integrate 2x, you get x squared. Now let's proceed. Our ZP will be, if we get rid of this 1 over d1 squared, 1 over d1 is like, we integrate this one to get rid of this one. If you integrate with respect to x, you'll get a half x squared y minus a third x cubic. So minus a third x cubic. Now this is our particular, this is the particular integral. Now this is our particular integral. So you are asked to solve completely. If you are asked to solve completely, you get the complementary function and the particular function. So this is the particular, and we had, we loved our complementary solution. So this is our particular solution. So to get the complete solution, you just add z complete solution is just equals to ZC, the one that we got first, plus. Hello everyone, welcome to my YouTube channel.